Good morning, students. Hope you are fine and doing well. Once again, heartily welcome to the online classes. Hope you have taken a break during the few days that we have given to you from online classes. At the same time, hope you have gone through the earlier concepts that you have learned during the earlier online classes. So, coming to our current topic, we are discussing the concepts of light. In the earlier classes, we have started with the concept refraction of light at plane surfaces. So, while dealing with the refraction of light at plane surfaces, what is meant by refraction? How do the light ray refracts at an interface? What is refractive index of material of the prism? What is refractive index of material of a medium? And what is Snell's law? What is Fermat's principle? Later we have discussed about the concept of total internal reflection of light. And then we have gone through a concept of refraction of light through a glass slab. So a glass slab is a double refracting medium. That means which makes the light to refract twice when we allow the light to travel through it. And moreover, the two refracting faces in the glass slab are parallel and plane. They are plane surfaces, even the refracting surfaces of the glass slab are plane and parallel to each. Now, we are going to discuss the concept of prism and the refraction of light. Usually, if you are going to refer the textbook, after discussing the refraction of light through a glass slab, there will be concept of lenses and all. In the next lesson, which is headed as human eye and colorful world, in that lesson there will be a concept of prism. But in order, usually, once we have discussed refraction through glass slab, which is a double refracting medium, in which the two refracting surfaces are plane and parallel. Usually, it is better to discuss refraction of light through a prism. Then we will come back to lenses. So remember, it is given in the next lesson, human eye and colorful world, but in order we are going to continue the topic refraction of light through a prism. This is our topic. The reason is a prism is also a double refracting medium. A prism is also a double refracting medium. Of course, whenever you said it is a refracting medium, it should be made up of transparent material. It should be a transparent medium. That's the default. Whenever it is a refracting medium, it is a transparent medium. So a prism is made up of a transparent material and which is a double refracting medium and can be bounded by any number of faces. Can be bounded by any number of faces. Why I am telling you it is bounded by any number of faces, because your prism is a closed arrangement, and moreover your prism is a three-dimensional object. It's a three-dimensional object, and it is a closed one. It is an enclosed arrangement bounded by any number of faces. So, whenever you are going to define a prism is a double refracting medium, which is a transparent material medium. Can be bounded by any number of faces. But here the point it is, the two refracting surfaces of the prism are not parallel. Whereas in the glass slab, the two refracting faces are parallel and plane. Even though here the two refracting faces are plane but not parallel. So to understand in detail, let me give you the three-dimensional figure of the prism. See, look at this. Once observe how I am going to draw the three-dimensional figure of the prism. Join the respective vertices. Join the respective corners. Corresponding corners you try to join. 1 minute. You can name this as A, B, C. Here it is D, E, F. So here, if you are going to look at the three-dimensional figure of the prism, you can see what is the base of the prism in the figure. What is the base? B, E, F, C will be the base of the prism. You can see on what base the prism resides. B, E, F, C will be the base of the prism in the picture. B, E, F, C will be the base of the prism in that particular arrangement. You can see the two refracting faces which are plane and parallel. One is A, D, E, B. The other one is A, D, F, C. So I am writing A, D, E, B and A, D, F, C are the two refracting faces of the prism. Which are plane but not parallel. So a prism is a three-dimensional one which can be enclosed by any number of faces. But remember, the two refracting faces of the prism are plane but not parallel. There will be some angle. You can see geometrically A, D, E, B, A, D, F, C. In between them there is some angle here. There is some angle. That will be treated as angle of prism. Which is represented by the letter capital A itself. Capital A stands for angle of prism. What is meant by angle of prism? The angle between the two refracting faces of the prism is defined as angle of the prism. See, when you are going to look at the placement of the prism, the front view of the prism is appearing to you just like a triangle. The front view of the prism, whatever you are seeing, will be appearing just like a triangle. So when I wish to draw a prism on the board in the coming classes, I don't draw the entire three-dimensional picture of the prism. I show you only the front view of the prism, which is triangle in shape A, B, C. Whereas the refracting face A, D, E, B is represented by AB, and the refracting face A, D, F, C is represented by AC. I repeat, here we have two refracting surfaces which are plane but not parallel. Here this refracting face is represented by AB. This refracting face is represented by AC in the front view of the prism. Then the angle between these two refracting faces of the prism is angle of the prism. If each angle in this is 60 degrees, then we call it as, I told you, I am telling you once again, if each angle in this prism, all the three are 60 degrees, what does it mean? Here the angle between faces 60 degrees. Here between these two is 60. Here between these two is 60. If each angle in the prism is 60 degrees, then we call it as equilateral prism. If one of the angles is 90 degrees, then we call it as a right angle prism. If one angle is 90 degrees and the other are 45 and 45, then we call it as a right angle isosceles prism. So, if each angle in the prism is 60 degrees, it is equilateral prism. If one of the angles is 90 degrees, right angle prism, you can show like this. Right angle prism, A, B, C, here is it. If the other two angles are 45 and 45, then it will be right angle isosceles prism. So the conclusion is, a prism is a transparent material medium and a double refracting medium in which the two refracting surfaces are plane but not parallel. Next point. The angle between the two refracting faces of the prism is angle of the prism. Based on angle of the prism, we can have different types of prisms. Later, when we are going to draw the picture of the prism on the paper, we take the front view of the prism, which is a triangle in shape, because your prism is placed on its rectangular base. Have you seen? BEFC. So the prism is placed on its rectangular base. That's why the front view of the prism will be triangle in shape. So that front view we are going to show on the picture. Then AB and AC will represent these two refracting surfaces respectively. Then the angle between these two faces will be angle of the prism. So this is all the basic introduction to the concept of the prism. Now we see, if a light is allowed to travel through a prism, how the light gets refract when it is allowed to travel through a prism. So our topic is refraction of light through a prism. Of course, in the coming session, slowly I will let you to see the prism, and then you can get more clarity on seeing the activity related to the prism. So this is all the three-dimensional picture that you can take on the paper regarding the prism, which you need to practice it, which is a three-dimensional figure. Go through it. So now our topic is refraction of light through a prism. So you are going to see the front view of the prism. A, B, C is our front view of the prism. Then the angle between the two refracting faces. What are the two refracting faces? One is AB, another one is AC. You can look into the earlier figure. The side AB represents one of the refracting faces, which is A, D, E, B. You can look into the earlier figure. The original figure of the prism, three-dimensional figure which we have drawn. A, D, E, B. That particular refracting phase will be represented by AB. And the other refracting phase, of course, A, D, F, C. A, D, F, C is represented by AC. So the angle between the two refracting faces is angle of the prism. Now we are going to discuss how the light refracts through a prism. So whenever we are going to allow the light to travel through a transparent material medium, you come across 2 points, whether your light is white light or whether your light is monochromatic light. I repeat, white light. White light consists of different wavelengths, means different colors which are present in it. Even you have got introduction in the earlier class also. Here monochromatic light. Monochromatic means light of single wavelength, light of single color. No more wavelengths will be present in it. There is only one wavelength, only it's a unique color, which we call it as monochromatic light. So let us discuss first monochromatic light is allowed to travel through a prism. How it refracts, we discuss. I repeat, what is monochromatic light? A light of single wavelength and of unique color is known as monochromatic light. If the light consists of two or more wavelengths within it, just like a white light has many more wavelengths that are present in it, I mean sunlight. Of course, we will be able to separate them when we allow white light to travel through a prism. We will be able to distinguish them separately. You will come to know in the coming classes. But now here we are talking about monochromatic light. Light of single wavelength, unique color is known as monochromatic light. Maybe red color of particular wavelength, blue color of a fixed wavelength, green color of some fixed wavelength. We call it as monochromatic light. Such monochromatic light is allowed to travel through a prism. Now look at this. Here is your incident light. You can suppose PQ is your incident light on the prism, where Q is the point of incidence. Now you have to draw a normal at the point of incidence to the refracting phase. This is a normal N1, let us suppose. So that the angle between the incident light ray and the normal at the point of incidence is angle of incidence, I1. Now as it is traveling from air to glass, my prism is made up of glass, let me suppose. Traveling from rarer medium to denser medium, so that it has to bend towards the normal. So this is actual path of the light in the absence of prism. But due to the prism, due to the refraction, it bends towards the normal. So you can name it as QR. Is the refracted path of light in the prism, QR. So this will be angle of refraction at the face AB. Now this refracted light ray becomes incident light ray for AC. Now draw the normal at the interface AC. Name it as N2. This is one normal which is N1. This is another normal. Now here, this will be angle of incidence because angle between incident light ray and normal at the point of incidence. And as it is traveling from glass to air, it has to bend away from the normal. Look at this. The light bends away from the normal. Now this will be angle of refraction. So once look at this. PQ is a monochromatic light ray that falls on the face of the prism AB. Then it refracts along QR and then emerges along RS. RS is emerging light. Whereas PQT is the actual path of the light ray, of course. Now you see, I1 is angle of incidence at the interface AB, R1 is angle of refraction. Now here again this is angle of incidence and this is angle of refraction. See, let me name this angle of incidence is R2 and this angle of emergence R refraction is I2. Usually people may stuck here. So here, when the light falls on AB, angle of incidence I1, angle of refraction R1. Then when the light falls on AC, why don't you take the angle of incidence as I2 here? Why don't you mention the angle of refraction R2 here? Why did you mention them as R2 and I2? Usually people may stuck with the notation. See, there is no secret behind it. This is the usual formal notation that was followed since from long earlier days. But a simple logic what you need to understand, you can connect the principle of reversibility. See, when I am dealing with the light is traveling from left to right through my prism, I1 R1, so that the remaining angles. But while dealing with principle of reversibility, if this is my incident light ray, then this will be my emerging light. I repeat, when PQ is the incident light ray, RS is emerging light ray. If RS is incident So the point it is, I1 is the angle of incidence at AB and R1 is the angle of refraction. The refracted light ray QR within the prism will be incident light ray at AC at an angle of incidence R2 and the angle of emergence I2. I2 can be treated as angle of emergence, at what angle my light ray is coming out of the prism. So this is how your light will get refracted through a prism. Remember, your incident light is monochromatic light. Of course, if you go in detail, PQT is the actual path of the light in the absence of the prism. But my light is emerging along with the path RS. PQT is the actual path of the light, but your light is emerging out along RS from the second interface AC. The light is emerging out along RS. So if you extend back a little, this will be taken as the deviation in the path of the light. Look at this. This angle will be the deviation in the path of the angle between actual path of the light PQT and the emerging path of the light RS will be the angle of deviation, can be represented by the letter D. Angle of deviation. You can look at this properly. If you see this triangle for a minute, you can name here some M. There is no problem. QMR. Look at this triangle. QMR. Then this angle TMR will be the angle of deviation, which is exterior angle. Angle TMR will be the angle of deviation, which is the exterior angle for QMR. Exterior angle. This will be. So that the exterior angle is equal to sum of the two interior angles. Means I can write D is equal to here this angle plus this angle, because exterior angle equal to sum of the two interior angles. So I can write angle MQR plus angle MRQ. MQR means this angle. MRQ means this angle. This is very simple actually. Don't be panicked. Angle of deviation. The angle between the actual path of the light PQT and emerging path of the light MRS will be angle of deviation. That's the first point. Second point. Why there is a deviation? Because the light is refracted by the prism. How many times light is refracted by the prism? 2 times. Where at AB and also at AC. Coming to A. Your light falls at an angle I1. Refracts at an angle R1. Then deviated by what angle? I1 minus R1, which you learned in the earlier basics first topic. If the light falls at an angle I1, refracts at an angle R1, as it is traveling from rarer to denser, R1 is less than I1 because it bends towards the R1. So angle of deviation I1 minus R1 plus here it falls at R2, bends away from the normal at I2. So that due to the refraction at AC, angle of deviation is I2 minus R2, because I2 greater than R2 as it bends away from the normal. So deviation brought by AB plus deviation brought by AC will be equal to the deviation in the path of the light. So that I can say angle of deviation D equal to I1 minus R1 plus I2 minus R2. I am writing here once again. I1 minus R1 plus I2 minus R2. This is the angle of deviation brought by AB. This is the angle of deviation brought by AC. Therefore, D equals to, let me write like this, I1 plus I2. Take minus common, R1 plus R2. So D equal to I1 plus I2 minus R1 plus R2 will be the angle of deviation. So keep it as it will come back to it. Apart from that, if you are going to put here N notation on joining the two normals N1 and N2, you can see your, look at this properly, your Q N R A is a quadrilateral. You can write like this also. A Q N R is a quadrilateral, means with four sides, A, Q and R. In that quadrilateral, sum of the opposite sides means angle A plus angle N. Let me write like this: angle QAR plus angle QNR equal to 180 degrees. Angle QAR, nothing but angle of the prism. Angle QNR means here angle. In this triangle QNR, this is R1, this is R2, so this should be 180 minus R1 plus R is equal to 180. Hope you have understood. Angle at N will be 180 minus R1 plus R2 because QNR is a triangle. Then angle at N will be 180 minus R1 plus R2. So this 180 gets cancelled here. Then take R1 plus R2 to that side, then minus becomes plus. So A is equal to R1 plus R2. So whenever you have got A is equal to R1 plus R2, take it as a first equation. Then angle of deviation D equal to I1 plus I2 minus R1 plus R2 can be replaced with A. Take it as a second equation. So when the light is refracting to a prism, if I1 R1 and I2 R2 are the angles of incidence and refractions, then A equal to R1 plus R2, D equal to I1 plus I2 minus A. This is the basic mathematical knowledge that you need to learn about the refraction of light through a prism. So you see, I1 is the angle of incidence, R1 is the angle of refraction. Here R2 is the angle of incidence, I2 is the angle of emergence. So usually people may get doubt. Sir, if I am going to increase the value of I1, look at this. For example, I1 is taken as 30 degrees. Then you will get some value for R1. So that there will be some value for R2 because R1 plus R2 equal to U. So that there will be some value exists for I2. But the point is, if I1 increases from 30 degrees to 35 degrees, I1 increases. When I1 increases, R1 has to increase. Snell's law concept. Sin A by sin R is always constant. When I1 increases, R1 increases. When R1 increases, R2 should decrease because R1 plus R2 is always equal to A, which is very important point. So as I1 value increases from 30 to 35, R1 value will increase according to Snell's law. But R2 should decrease because R1 plus R2 should be equal to A. So when R1 increases, R2 should decrease. When R2 decreases, I2 should decrease because Snell's law at AC. When R2 decreases, I2 should decrease. So when I am going to come across the values of I1 and I2, I1 increases, R1 increases, but R2 will decrease, so that I2 will decrease according to Snell's law. So if you are going to increase the value of I1 increases slowly, but the value of I2 gradually decreases. So what you need to understand, when I1 value is going to increase, I2 value is going to decrease. So at one time I1 can be equal to I2. Have you seen? When I1 value is going to increase, I2 value is going to decrease. So their numerical values are moving in opposite manner, increasing and decreasing. So at one time I1 equal to I2. So what's up? So what? Why are you telling all these stories? So okay, let it be I1 equal to I2. So what? This is a mathematical point what we need to understand. As D equal to I1 plus I2 minus A, whenever I1 equal to I2, the sum of these two values will be minimum. If X and Y are two non-zero numbers, their sum will be minimum when X equal to Y. So if I1 equal to I2, yes, there is a possibility, then the angle of deviation will be minimum because the sum of I1 plus I2 is minimum. So let me take I1 equal to I2, let us take it as I simply. Then D equal to I plus I, because D equal to I1 plus I2 minus A. when I1 equal to I2, angle of deviation is minimum. Then D minimum equal to I plus I, 2I minus A. This is angle of minimum deviation. So that whenever angle of minimum deviation is 2I minus A, with I1 equal to I2, then R1 will be equal to R. Because when I1 equal to I2, R1 will be equal to R2. So that R1 is equal to R2, let me take it as R. Then angle of prism A is equal to R1 plus R2, you know. So A is equal to 2. So these are all the points only at a minimum deviation condition. I repeat the word. Minimum deviation. When the light is allowed to travel through a prism, due to the refraction at the two interfaces, there is a deviation in the path of the light. That deviation will be minimum when I1 equal to I2, because D equal to I1 plus I2 minus A. Sir, is there possibility? Yes, you can see. When I1 increases, R1 increases, Snell's law. But R2 should decrease because R1 plus R2 equal to A. When R2 decreases, then I2 decreases. Means as long as I1 increases, I2 will decrease. So at one instant of time, I1 will be equal to I2, where the sum is minimum. So automatically this deviation will be minimum. So minimum deviation formula 2I minus A and R1 equal to. In such condition, at a minimum deviation condition, whenever I1 equal to I2 with R1 equal to R2, remember your refracting light ray will be parallel to base of the prism. This is I1 and this is R1, this is R2 and this is I1. I told you this is at a minimum deviation position. I1 equal to I2, R1 equal to R2. So as per geometry, the refracting path of the light should be parallel to base of the prism, because R1 equal to R2. That is what we need to understand. So this is how we derive equations for angle of minimum deviation and angle of the prism A is equal to 2R. Sir, why do we are discussing all these things? You may get that out. Sir, why do we are discussing? You just wait. I am going to tell you an important point. The purpose of dealing with all this mathematics. But remember what topic we are dealing? Refraction of light through a prism. When a monochromatic light is allowed to travel through a prism with angles of incidence and angles of refraction, then what will be the mathematics involved? Means A equal to R1 plus R2, D equal to I1 plus I2 minus C. Now we are going for a special condition. What is the special condition? Minimum deviation. I am expecting my light ray should come out of the prism with the minimum deviation. When it happen? When I1 equal to I2. I1 is the angle of incidence, I2 is the angle of emergence. When both are equal, then that is the minimum deviation condition. So then angle of minimum deviation 2I minus A, angle of the prism A equal to 2R, because when I1 equal to I2, R1 equal to R. Let me suppose as R. So this is what you need to understand. Now we come into the main mathematical concept. Just go through it. So now see, we have discussed with the angle of minimum deviation 2I minus A and angle of the prism A equal to 2R. Then from this, D minimum plus A is equal to 2I. Then D minimum plus A by 2 equal to I. Whereas A equal to 2R, then R is equal to A by 2. Once I have got I1 and I2, R1 are the values, then I can apply Snell's law at AB. Snell's law at AB, I am applying. What is Snell's law at AB? Refractive index of A into sin I1 equal to refractive index of glass into sin R1. But I told you at minimum deviation condition, I am writing here once again. At a minimum deviation condition, I1 equal to I2 is equal to I. R1 is equal to R2 is equal to R at a minimum deviation condition. Then refractive index of A1 into sin I is equal to your refractive index of glass N. Let us suppose refractive index of material of the prism of the glass N into sin I. Then N equal to sin I by sin R. That is N equal to sin of I value A plus minimum deviation by 2 by sin R value A. So this is my intention to give you a mathematical formula to calculate the refractive index of material of the prism. N equal to sin of A plus dm by 2 by sin of A by 2. This is the concept. So, I am going to come to when you are going to deal with the refraction of light through a prism, I1 is the angle of incidence at AB, R1 is the angle of refraction. Then the refracted light QR in the prism will be the incident light ray for AC. Then R2 is the angle of incidence, I2 is the angle of refraction. Of course, this is the angle of emergence also. The angle between actual path and emerging path is angle of deviation. So whenever you are dealing with all these concepts, the important mathematical formula you come across it is the refractive index of material of the prism, sin of A plus dm by 2 by sin of A by 2, where A is angle of the prism, D minimum means angle of minimum deviation. I told you, if you are going to increase the value of I1, then the value of I2 gradually decreases. At one time I1 equal to I2. Then angle of deviation will be minimum. So angle of prism will be already given in the data. Then what you should calculate for the angle of minimum deviation. So you remember this formula, which is to calculate the refractive index of material of the prism. Especially for state board students, this all derivation is in textbook, which can be given for public examination. For CBSE students, even though it is not there in the textbook, but it is very important to go through it, which will be helpful to you.